Hey guys, so today we're going to go over background 9 color mixing and how all this stuff works. So first thing is how we see. We see the light reflected off of objects. So you have light coming in from something like a ceiling light, and then it hits like something like a blue shirt, and then that light color blue is reflected off of the shirt into your eyes, and then you see that reflected light, and because only the blue light is reflected, then you see the blue. So my shirt absorbs colors other than blue, so it'll reflect the blue, and that's what you'll see. So next is frequency, wavelength, and color. All light waves have a frequency and wavelength, and light waves do not have color. The cones in our eyes can determine the frequency of light in the visible spectrum, and then the brain translates this frequency to a color perceived in our vision. So there's again light coming out of the ceiling light over here, and that light has lots of different frequencies. That light bulb spits out light of all these frequencies in this visible range, and then my brain sees that light, and when light hits the retina and the cones, then my brain translates. The cones can detect that frequency. My brain translates the frequency into color. So if you were to look at this yellow wall, then what's coming into your eyes is light of this frequency over here, and then your brain detects that frequency, and then you perceive it as color. So light does not have a color, it has frequencies which you perceive as color. We can use this fact to trick the brain into perceiving colors of light where they don't exist, and that's what we're going to cover over here. Additive color mixing is combining light waves of different frequencies to create the illusion that the light is of an intermediate frequency. So in this image, there is red light, green light, and blue light. And as you can see, as this red light and green light mixes, it creates yellow light. And as this blue light and red light mixes, it creates this pink light. As this blue and green light mixes, it makes this cyan light. So what's coming out of the screen right here on this yellow is not a yellow light. The computer screen that I'm looking at has red little red light bulbs, little green light bulbs, and over here it is turning on the red and the green light bulbs. So the red and green frequencies hit my eyes at the same time. And my eyes are like, okay, we have two frequencies. So it sends it to the brain, and the brain says, then the brain translates that into what I perceive. So the brain has these two frequencies, red and green. It says, should I make this thing red? Should I make it green? And what the brain does is it puts it somewhere in the middle. So it makes it yellow instead. But there is no yellow light bulb here. There's no yellow light bulb. It's a red light bulb and green light bulb. You have like gazillions of red and green light bulbs in your computer or iPad or phone, and your brain sees that red and green light at the same time and perceives it as yellow. There's no light of the yellow frequency coming out. It's red and green, but your brain perceives it as yellow. And then when you mix red, green, and blue light all together, then you get what looks to be white light out here. Here's an example of that in a different picture. So red light, green light, blue light makes this beautiful picture. Yeah. Okay, this is subtractive color mixing. So here we have, what is this, magenta, cyan, and yellow. And so mixing magenta and yellow pigments makes a red pigment. Mixing magenta and cyan pigments make a blue pigment, and mixing blue and yellow pigments makes a green pigment. And you can see that here. When you mix all three pigments, then you get a black pigment. Nothing super interesting about that. That's just, it's like your third grade art class. But this is how our printers work. They have this cyan, magenta, yellow, and black, or black gray, depending on your printer, and then it comes out like another beautiful picture. Okay, so let's practice with all this a little bit. So this is very helpful. This is also very helpful. I prefer to use this picture. Some people prefer this picture. They both have the same exact information. One is not any more helpful than the other. I just prefer this picture. When you're working, you can use whatever you like. So here we have white light shined onto a cyan pigment. So that's down here. You see the cyan pigment, and then only the green and the blue light is reflected. So white light, and I say white because red, green, and blue light mixed together is white light, shined onto a cyan pigment, and what's reflected is only green and blue. But we know that green and blue combine to be cyan. So if you have white light shined onto a cyan pigment, then you get cyan reflected, which is what this says here. Here, this is what's a cyan and yellow pigments together. So what do we get when you mix cyan and yellow pigments? Green pigments. So this is a green pigment. So they shine light onto a green pigment. The red light and the blue light are absorbed, and only the green light is reflected. So if we shine white light onto a green pigment, then we see it to be green. So that's how this picture works. There's one mistake. This should be this yellow. I don't know why they highlighted it pink, but that should be a yellow. Yellow Y. That's what I meant. Okay, let's do some harder ones. Let's say you shine. So let's draw this. We have red light coming in. Let's say there's blue light coming in, and then a green pigment. It's a green pigment that is going to be yellow and blue, yellow and cyan. So this can be cyan and yellow pigment. And what is reflected? Well, we look at this picture. We got a green pigment made out of yellow and cyan, red and blue light shining in, and neither is reflected. So this is nothing reflected. Nothing is reflected. And the absence of light is perceived as black. So you see what's perceived? Black. Yay. Alright, let's do another. You got let's do I don't know if I spelled that right. That's okay. Let's draw this again. We got red and blue light coming onto our yellow pigment. What is perceived? So in this picture right here, we have red, blue, and green light. But in our question, we only have red and blue light. So we just ignore the green because the green is not a part of our problem. And then we see that when we have a yellow pigment, red and green are both reflected, but we have no green to start, so we have no green reflected. So only the red light is reflected. So this is perceived as red. Okay, let's do one more. So we got what I say? Red, blue, and green. We got red light, blue light, and green light on a blue pigment. So blue is made up of blue is made up of cyan and magenta. Let me get some magenta. Is that magenta? Maybe that one. Magenta. What is reflected? Well, in this picture at this bottom right here, we see when you shine red, blue, and green light onto what is this? Red, blue, and green light onto a blue pigment, and blue is made out of what is this? Cyan and magenta. Then only blue light is reflected, and so this is perceived as blue. Yay! So these are not very complicated, not too difficult. You just take your steps to go through it. I'll do one more. Last one. Say you have red and green light shined onto a cyan pigment. So as we can see from this picture, when you shine red, green, and blue light onto cyan pigment, then the green and blue is reflected. However, here we have no blue light, so no blue light will be reflected. Here we only get green reflected, and this is perceived as green. Yay! Okay, that's all there is to it. I hope this helps. There's nothing super complicated. Just go step by step. Be very careful with each problem. Draw these pictures if it helps you. That's everything.